Lesson L018, AI in Education.
Welcome to Lesson 18, where we explore the transformative impact of artificial intelligence on education. Education is one of the most fundamentally human activities, and AI is poised to reshape it in profound ways. We will cover adaptive learning platforms, personalized tutoring, AI in classrooms, skill gap analysis, lifelong learning, and the flipped classroom model with AI. Each topic reveals how AI can make education more effective, accessible, and personalized than ever before. The scale of the opportunity is enormous. There are over 2 billion students and teachers worldwide, and the global education technology market is projected to reach over $680 billion by 2030, with AI playing a central role in that growth. Let us begin with adaptive learning platforms, which represent one of the most mature applications of AI in education. An adaptive learning platform uses AI algorithms to adjust content, pace, and difficulty in real time based on each learner's performance. Instead of a one-size-fits-all curriculum, each student follows a unique path tailored to their strengths and weaknesses.
The best-known example is Khan Academy, whose adaptive engine uses a model of knowledge mastery rather than simple right or wrong scoring.
When a student answers correctly, the system increases difficulty. When they answer incorrectly, it provides hints, shows instructional videos, and offers simpler practice until the student demonstrates mastery. Khan Academy builds a detailed knowledge map for each student, showing exactly which concepts have been mastered.
Another prominent example is Duolingo, with over 500 million users worldwide. Duolingo uses spaced repetition to schedule reviews at optimal intervals and an adaptive skill tree that changes based on performance. The system tracks tens of thousands of data points per user, including response time and accuracy by skill. Research has shown that 120 hours of Duolingo usage is roughly equivalent to one semester of university-level language instruction. ALEX, widely used in higher education for mathematics and science, uses knowledge space theory to model the entire domain as a network of interconnected concepts. Studies show that students using ALEX achieve significantly higher exam scores compared to traditional instruction. The key insight behind all adaptive platforms is that students learn best when instruction is tailored to their needs, and AI makes this personalization possible at scale. Personalized tutoring addresses a fundamental limitation of traditional schooling. In a typical classroom, one teacher manages 20 to 30 students with different learning speeds and styles, and cannot provide individual attention to everyone. AI-powered intelligent tutoring systems aim to bridge this gap. Carnegie Mellon University's Cognitive Tutor, developed in the 1990s, was an early pioneer. It uses a cognitive model of how students think and provides step-by-step feedback as students work through problems. The system identifies exactly where reasoning went wrong and provides targeted hints. Research found that students using Cognitive Tutor performed about one standard deviation better than students in traditional instruction, a result replicated across multiple schools and thousands of students. More recently, large language models have enabled a new generation of AI tutors that can engage in natural conversation. Khan Academy's Canmigo, powered by GPT-4, acts as a guide rather than giving away answers. When a student asks for help, Canmigo asks guiding questions like, "What do you think the first step should be?" Or "Can you explain why you chose that operation?" This Socratic approach encourages active learning rather than passive consumption. The system also provides creative writing feedback, debate practice, and conversations with historical figures. Another notable system is Squirrel AI in China, which serves over 2 million students across more than 2,000 learning centers. It uses reinforcement learning to optimize each student's learning path in real time, analyzing hundreds of dimensions including knowledge state, learning speed, attention patterns, and even emotional state through facial expression analysis. The company claims a 93% improvement in learning efficiency, and while these claims should be evaluated critically, the general trend is clear. AI tutoring systems are approaching the effectiveness of human tutors for certain subjects and skill levels, and they are available 24 hours a day at a fraction of the cost. AI in the classroom extends far beyond tutoring. Automated grading is one of the most practical applications. AI can grade multiple-choice questions instantly, and advances in natural language processing allow it to grade essays with reasonable accuracy. Turnitin and Grammarly use AI to provide feedback on writing quality and originality. While AI grading is not as nuanced as human grading,
it dramatically reduces time on routine assessment, freeing teachers for more meaningful activities.
Another important application is early intervention. AI systems analyze student engagement data to identify those at risk of falling behind.
The University of Arizona uses an AI system that analyzes login patterns, assignment submissions, grade trends, and library usage to predict which students are likely to struggle, generating alerts so advisors can reach out proactively. This kind of predictive analytics has improved retention rates by 5 to 15% at institutions that implement it effectively. Classroom management tools like ClassDojo use AI to track behavior and engagement patterns, providing data-driven insights about classroom dynamics. AI-powered transcription tools automatically caption lectures, benefiting students with hearing impairments and non-native speakers.
Translation tools bridge language gaps in multilingual classrooms.
All these applications share a common theme: AI handles routine tasks so that teachers can focus on building relationships, inspiring curiosity, and providing emotional support. A study by the OECD found that teachers who used AI tools effectively reported higher job satisfaction and were better able to meet individual student needs. Skill gap analysis is a critical function of AI in education and workforce development. A skill gap is the difference between the skills a person has and the skills required for a particular job or educational outcome. Identifying these gaps efficiently is essential for individuals, educational institutions, and entire organizations. AI-powered skills assessment platforms use natural language processing to analyze job descriptions, course curricula, and learner profiles to identify precisely which skills are needed and which are missing.
LinkedIn's AI powers its skills assessment feature, allowing users to demonstrate proficiency in specific skills and match those to job requirements. The platform analyzes millions of job postings to identify which skills are in demand and which are becoming obsolete.
LinkedIn's data shows that demand for AI skills has grown by over 300% in the past 5 years, while demand for traditional data entry skills has declined by over 40%. This kind of real-time labor market intelligence is invaluable for educational institutions designing curricula and for individuals planning their careers.
Coursera uses AI to analyze skills gained through courses and match them to in-demand job roles.
Its skills graph maps relationships between hundreds of thousands of skills across different domains, showing which skills lead to which career paths. For example, learning Python, statistics, and machine learning typically leads to data science roles, while JavaScript and cloud computing lead to front-end development. A university might use AI for curriculum gap analysis, discovering that its computer science program lacks cloud computing or AI ethics coverage, and receiving specific recommendations for updates. On an individual level, platforms like Pymetrics use AI assessments to match cognitive and emotional traits to potential career paths, identifying not just gaps but also aptitudes worth developing. These systems help people make more informed decisions about their education and careers based on data rather than guesswork.
Lifelong learning is increasingly essential as professional skills become obsolete faster than ever. The half-life of professional skills in technical fields like AI and software development is now estimated at 2 to 5 years. Continuous learning is not optional for most professionals. AI-powered platforms like Udacity, edX, and Coursera recommend courses, personalize learning paths, and provide automated feedback. When a new programming framework is released, AI can identify which course modules need updating and sometimes even generate updated examples. Micro-credentials and digital badges, verified by AI proctoring systems, allow learners to demonstrate specific skills without committing to a full degree program. AI-powered proctoring uses computer vision and behavioral analysis to ensure assessment integrity, though it raises privacy concerns. Tools like Otter.ai record and transcribe meetings and lectures, creating searchable knowledge bases. Notion's AI features summarize documents and generate study guides. Readwise uses AI to surface previously highlighted content at optimal intervals for reinforcement. The key challenge for lifelong learning is motivation. AI addresses this through gamification and personalized nudges. Duolingo's Daily Streak feature, which uses AI to determine optimal notification timing, significantly increases user retention. The platform predicts which users are at risk of quitting and intervenes with targeted encouragement. These same techniques are now being applied to professional learning platforms to help busy adults make consistent progress. The flipped classroom model has existed for over a decade, but AI is making it far more effective.
In a traditional classroom, students listen to lectures during class and do problem sets at home.
The flipped model reverses this.
Students watch lectures or read materials at home, then use class time for active problem solving, discussion, and collaborative projects. The idea is that passive content consumption can be done independently, while active learning benefits from teacher presence and peer interaction.
AI enhances the flipped classroom in several ways.
First, AI can personalize the pre-class content for each student based on prior knowledge and learning preferences, assigning different readings or videos to different students. Second, AI ensures students actually engage with pre-class material. Platforms like Edpuzzle embed questions into videos, and AI analyzes responses to identify concepts needing more attention during class. Third, and most importantly, AI optimizes the use of limited class time. When students arrive, the teacher receives an AI-generated summary showing which concepts are mastered, which need clarification, and which students need individual help.
The teacher can then allocate time precisely where it is most needed. Some advanced implementations use real-time classroom analytics.
Sensors and AI track which groups are progressing on collaborative work and which are struggling.
The teacher receives live updates and can intervene exactly where needed. Research on AI-enhanced flipped classrooms is promising.
A meta-analysis of 32 studies found that the flipped classroom combined with AI-driven personalization produced an effect size of 0.67, meaning students performed about two-thirds of a standard deviation better than those in traditional settings. This is roughly equivalent to moving a student from the 50th to the 75th percentile in academic performance, a substantial and meaningful improvement by any educational standard. Looking toward the future, several trends are worth watching. Multimodal AI systems that process text, images, audio, and video simultaneously will enable richer educational experiences. Imagine a biology student pointing their phone at a plant and having an AI tutor identify the species, explain its ecological role, and quiz them on related concepts. Virtual reality combined with AI tutoring could enable immersive learning experiences, like practicing a foreign language in a simulated marketplace or conducting virtual chemistry experiments without safety risks. The ultimate promise of AI in education is not replacing teachers but helping every learner, regardless of geography, income, or background, access a world-class education tailored to their individual needs. This vision is ambitious, but the technology is advancing rapidly and the early results are genuinely encouraging. The key takeaway is that AI in education is not about replacing human teachers but about amplifying their impact and reaching learners who currently have no access to quality education at all.